Good morning, everyone, or good day. I want to thank you for the opportunity of being talking to you. I've been working. I'm not part of the consortium, but the idea here is to share my work in intent to join eventually on the processes of multiscale modeling and computational setup for this. I want to share with you the what I've been doing. So here is regards the problem of multiscale applied to the coupled system of water and heat exchanges near the soil surface or subsurface. And the outline, I would just describe the motivation into the multi-scale problem and the setup and the contributions and the application for the couple system. So here is the motivation of what is the multi-scale is about, how the conductivity of, here is a scalar equation, the equation, how the conductivity varies locally, and then how to obtain so the idea is how to resolve this scale. And this is a nice small scale in a shale rock. When I was working in a project from Los Alamos and Chevron, Los Alamos National Lab and Chevron, and that we work in the beginning of the shale when it was setting up the exploration. And also, I want to just point it out that this is a problem that also happens in bone modeling, and I did have work on it. But what I want to introduce is how, giving a heterogeneity, how to um, substitute this heterogeneous for an upscale coefficient for each of the part of this domain. And we did some work on it. And there is a lot of work also that I've done using multigrid and numerical analysis. But what I want to show here is how this multiscale applied in soil hydrology. And this is result of a project that we did, NSF project. And this is the setup here, the motivation, that you see that the radar gets in kilometer scales and needs to capture the in situ, which is centimeters scale. So the idea is how to, this is a band of the Oklahoma where the satellite gives us this data. So we have worked the mathematical setup and the system of heat and temperature, and I will just pass here. So this is heat and pressure, water pressure, the coupling, but mainly how to describe the heterogeneity and how the upscale of this heterogeneity. And this is the energy balance equation for evaporating soil surface. And the idea how we did, there was a data already for collection moisture and temperature. And we use this data to check our model. So this model is against the data that's been collected in this site in 1D dimension. And my colleague Binayak Mohanty has extensive collaboration with NASA in data mining. So we had some experience how to use this data into this experiment. And here is checking again water pressure or moisture. And this is how we manage to capture also the variation in the temperature. And this is in the very near subsurface. The idea here is that I would like to point that I'm willing to work in this multi-scale application, and would like a collaboration if possible. And how would we do the same setup that is being in 1D to 3D version and coupling in a global climate model? So I want to thank you for your I want to thank you for your time.